Next, moving on to the digestive system. But I guess we have one more respiratory system related video question. So this is video question number one. Video question number one. In humans, which lung is larger? Which lung is larger? And the answer is the right lung. The right lung. And the reason why is your heart is on the left side of your chest, and your left heart has to make room for, sorry, your left heart, your left lung has to make room for your heart. And so your left lung is a bit smaller than your right lung. Okay, digestive system. First, a little overview. I thought it might be helpful in this case to see a little overview before we start to do, jump into some of the content. So here we go.
Across the whole planet, humans eat on average between 1 and 2.7 kilograms of food a day. That's over 365 kilograms a year per person, and more than 28,800 kilograms over the course of a lifetime. And every last scrap makes its way through the digestive system. Comprised of 10 organs, covering 9 meters, and containing over 20 specialized cell types, this is one of the most diverse and complicated systems in the human body. Its parts continuously work in unison to fulfill a singular task, transforming the raw materials of your food into the nutrients and energy that keep you alive. Spanning the entire length of your torso, the digestive system has 4 main components. First, there's the gastrointestinal tract, a twisting channel that transports your food and has an internal surface area of between 30 and 40 square meters, enough to cover half a badminton court. Second, there's the pancreas, gallbladder, and liver, a trio of organs that break down food using an array of special juices. Third, the body's enzymes, hormones, nerves, and blood all work together to break down food, modulate the digestive process, and deliver its final products. Finally, there's the mesentery, a large stretch of tissue that supports and positions all your digestive organs in the abdomen, enabling them to do their jobs. The digestive process begins before food even hits your tongue. Anticipating a tasty morsel, glands in your mouth start to pump out saliva. We produce about 1.5 liters of this liquid each day. Once inside your mouth, chewing combines with the sloshing saliva to turn food into a moist lump called the bolus. Enzymes present in the saliva break down any starch. Then your food finds itself at the rim of a 25 centimeter long tube called the esophagus, down which it must plunge to reach the stomach. Nerves in the surrounding esophageal tissue sense the bolus's presence and trigger peristalsis, a series of defined muscular contractions. That propels the food into the stomach, where it's left at the mercy of the muscular stomach walls, which pound the bolus, breaking it into chunks. Hormones secreted by cells in the lining trigger the release of acids and enzyme-rich juices from the stomach wall that start to dissolve the food and break down its proteins. These hormones also alert the pancreas, liver, and gallbladder to produce digestive juices and transfer bile, a yellowish-green liquid that digests fat, in preparation for the next stage. After 3 hours inside the stomach, the once shapely bolus is now a frothy liquid called chyme, and it's ready to move into the small intestine. The liver sends bile to the gallbladder, which secretes it into the first portion of the small intestine, called the duodenum. Here, it dissolves the fats floating in the slurry of chyme so they can be easily digested by the pancreatic and intestinal juices that have leached onto the scene. These enzyme-rich juices break the fat molecules down into fatty acids and glycerol for easier absorption into the body. The enzymes also carry out the final deconstruction of proteins into amino acids and carbohydrates into glucose. This happens in the small intestine's lower regions, the jejunum and ileum, which are coated in millions of tiny projections called villi. These create a huge surface area to maximize molecule absorption and transference into the bloodstream. The blood takes them on the final leg of their journey to feed the body's organs and tissues. But it's not over quite yet. Leftover fiber, water, and dead cells sloughed off during digestion make it into the large intestine, also known as the colon. The body drains out most of the remaining fluid through the intestinal wall. What's left is a soft mass called stool. The colon squeezes this byproduct into a pouch called the rectum, where nerves sense it expanding and tell the body when it's time to expel the waste. The byproducts of digestion exit through the anus, and the food's long journey, typically lasting between 30 and 40 hours, is finally complete. TED-Ed is a nonprofit. If you value our work, please consider supporting it on patreon.com/TEDEd.
All right. So yeah, that gives a good. Sorry, that gives a good little overview. So jumping in or rehashing some of those details, we have the four main steps or terms that are related to the digestive system. First, there's ingestion, which is just food intake, it's getting the food into your body. Then there's digestion, which is the breakdown of food to soluble substances. Then there's absorption, which is the movement of the soluble food molecules into the bloodstream, so that is your body absorbing the food that was digested. And there's egestion, the elimination of undigested and unabsorbed material. And then the digestive system gets broken down roughly into two groups. There's the alimentary canal, also known as the gastrointestinal tract. GI doctor like a digestive system expert, and the GI stands for gastrointestinal. I'm on my third GI specialist now. The first two, well, the first one I was working with for the first several years of Crohn's disease, he retired. And then I was working with another one for a little while, and then he retired. And then now, yeah, I'm on my third GI specialist. Anyway, the main parts of the alimentary canal are the mouth, the pharynx, the esophagus, the stomach, the small intestine, and the large intestine. And then there are accessory organs. And these are things like the teeth, tongue, salivary glands, your liver, your gallbladder, and your pancreas. So the alimentary canal is what the food actually travels through. And then the accessory organs are things that are connected or attached in various ways to what the food travels through and that help the digestion process in some shape or form. Then your GI tract has four tissue layers to it. The innermost is the mucosa, also known as the mucous membrane, and it's what comes in direct contact with the food, and it has mucus for protection. The protection is partially to keep foreign substances from getting into your body. In other words, like stuff that your body shouldn't absorb, the mucous membrane helps your body be selective about what it absorbs, but also protection of your body from digesting itself. So, like without a mucous membrane, your stomach would digest itself because the digestive acids inside your stomach would actually break down the stomach itself if it weren't for mucus providing protection. But then also lubrication so that the chyme can make its way through your body more easily. Then the next layer is the submucosa, and it's made up of some loose connective tissue and blood vessels and nerve endings. And the blood vessels serve the purpose of carrying away the dissolved nutrients. So that's where the absorption takes place. And then the nerve endings help stimulate muscle fibers to move the food. And then the third layer is the muscular layer, and that's the thickest of the four layers. It's a visceral muscle. Again, that's a smooth muscle. And then it produces peristalsis, where peristalsis is wave like contractions that move the food. And then the outermost layer is the serous layer, and it's mainly just connective tissue for holding the digestive organs in place. That's one of the differences, speaking of Crohn's disease, between Crohn's disease and ulcerative colitis, is ulcerative colitis affects just your colon and only these two innermost layers, the mucosa and the submucosa. Whereas Crohn's disease can affect any of your alimentary canal and it can affect all four of the tissue layers. Okay. Then kind of making our way from top to bottom of your digestive system. First is the mouth and teeth, and this is where the food is chewed, softened, and lubricated, and then starch is broken down into sugars. So the digestion process begins in the mouth with saliva. Saliva has enzyme in it that starts to break down starches, but usually it only breaks down some of the starches, not because the enzyme is insufficient, but because you swallow before it's finished doing the work. And then we just kind of mentioned salivary glands, the production of, saliva, and then taste buds also in your mouth, and then which partially is for enjoying the food, but also for deciding like what is safe and potentially unsafe to eat. And then teeth, the four kinds of teeth that humans have is incisors or are incisors, cuspids, premolars, and molars. And I'm not going to take the time to go into what those look like and what they do. You could check the textbook if you'd like more information for that. And the next is the pharynx, esophagus, and stomach. So when you swallow food, it takes about 3 seconds to travel through the esophagus to get from your mouth to your stomach. Yeah, about 3 seconds there. And then in your stomach is where you churn the food and mix the food with acidic gastric juices. And then your stomach can hold about 2 liters of food. So picture a 2 liter bottle. That's about how much food an average adult stomach can hold. And of the digestion that takes place is mainly proteins that get digested in your stomach. But then also there's some absorption that happens in your stomach, but mainly water, alcohol, and some drugs like medication kind of drugs, which I like. I know for me, when I'm having a flare up, um, there's an anti-inflammatory steroid, prednisone, that can do a really good job of getting some of the inflammation under control that is shutting down my small intestine. And it gets absorbed in your stomach, which I'm really glad because when my small intestine is getting shut down, the food in my digestive system stops moving, and so things are just kind of shut down. And so food from my stomach can't get into my small intestine because everything is backed up. And prednisone, because it gets absorbed in your stomach, all I have to do is be able to swallow the prednisone, and then my body can start to absorb the prednisone in my stomach, and then it can trigger a decreasing of inflammation at the end of my small intestine, which then lets things get functioning again. Let's see. So, speaking of the stomach, let's do video question number 5. Number 5. What man's gunshot wound in 1822 allowed a surgeon to learn a lot about digestion? So, what happened was there was a guy, he got accidentally shot by a fur trapper, and the gunshot created a pretty big hole in his abdomen that went into his stomach. So there was a hole in his stomach and then a hole in the outside of his body. And there was an army surgeon that stitched him up and they got it largely, stitched up so that it could heal. And it did heal, and the guy lived and was fine, but it didn't heal all the way. And there was a permanent opening, I want to say about like the size of a quarter, in his skin that then went also into his stomach. And so the surgeon, and knowing and seeing how this guy healed up, he saw it as an opportunity to experiment a lot on what happens with digestion in your stomach. So he could literally take like little bits of different kinds of food, tie a little string onto it, and then feed it through the hole directly into the guy's stomach and let it sit for different amounts of time, and then pull it out of the guy's stomach and observe what happened with the digestion. Anyway, so what was that guy's name that got the gunshot wound with the hole? His name was Alexis Saint Martin. Alexis Saint Martin. So Alexis I'm sorry, Alexis space St for Saint space Martin, Martin. Alexis Saint Martin. Yep. So interesting little tidbit about medical history, kind of. And then from the stomach, things move into the small intestine. The small intestine is about 1 inch in diameter and about 23 feet long. So it's called the small intestine or the small bowel. Most doctors tend to refer to it as the small bowel instead of the small intestine. But yeah, it's called small because it's a smaller diameter than your colon or large intestine. And it has three different parts to it. There's the duodenum, or as that video pronounced it, duodenum. Duodenum is technically more commonly said for pronunciation, but I way more commonly hear duodenum. And it's about the first 10 inches. And then the jejunum, which is about 8 feet long, and then the ileum, which is about 13 feet long. So, like in my Crohn's case, it's my terminal ileum, the end of my ileum, that repeatedly gets inflamed, and there's scar tissue buildup there to make it partially constricted. So that's for me about the last 6 inches of that 13 feet. But the ileum is where tons of the absorption takes place. So this mentions most of the digestion and absorption. Most of the absorption takes place in your ileum. So of those 13 feet, if you just removed like two or three of them, the person would probably starve to death without some kind of like intravenous, IV giving of nutrition because they could eat and eat and eat and eat and eat, and their body would not absorb enough of the nutrition to keep them alive. And then another characteristic of the small intestine are these villi. These villi are like these microscopic finger-like structures. So here you have an illustration showing kind of what the inside of the small intestine might look like with all of these villi. And they line the small intestine, the inside of the small intestine, and function to absorb the food molecules. And then here you have a diagram like one villus, villus singular, villi plural, and so it has these blood vessels running through it and capillaries, and then like some lymph nodes to help with your immune system. And then even the surface has even smaller villi called microvilli, and just tons of absorption of nutrients to get into the bloodstream. That's what's going on there. And then moving on to some of the accessory organs, we have the liver, the gallbladder, and the pancreas. And a few of the functions that the liver does. The liver engulfs bacteria and worn out red blood cells. So it serves that kind of cleansing function of getting some of that bacteria and dead blood cells out of your bloodstream. It also does stuff like removes drugs and poisons from blood and detoxifying them. It's like if you OD'd on a variety of stuff, both legal and illegal substances, the overdosing for a lot of stuff is that it can cause liver damage. So, like, even something like Tylenol, if you take too much Tylenol, the main way is going to hurt your body is it's going to cause liver damage because you're overloading your liver with too much stuff for it to work on detoxifying. And then the liver also changes excess glucose into fats, and it absorbs amino acids from the blood and uses them to manufacture most of the proteins found in the blood, and it stores fat soluble vitamins and iron and copper, and also forms bile. And bile is a greenish fluid necessary for the breakdown and absorption of fatty substances in the small intestine. So that takes us to the gallbladder. The gallbladder is about 3 or 4 inches long, and it's a green pear-shaped sac that is attached to the liver. So the liver produces bile, and then it sends it to the gallbladder, and the gallbladder serves as a reservoir of bile. And then the gallbladder passes bile onto your small intestine when it is triggered that you've eaten the kind of stuff that needs additional bile. And so then the gallbladder passes it on to your small bowel, your small intestine, when the time is right. And then there's your pancreas. It's about 6 to 10 inches long. So I mean, you think like upwards of a ruler, a foot long ruler in length. Kind of a pinkish white gland. The surface of it to be sometimes kind of slightly resembles cauliflower. And it produces digestive juices that contain enzymes for breaking down carbohydrates, fats, and proteins. Okay, so then the large intestine, also known as the colon, and it's about 2.5 inches in diameter, so 2.5 times as wide of a diameter as the small intestines. That's why the small intestine versus large intestine. Because lengthwise, the large intestine is usually about 5 to 6 feet long, so not nearly as long as like 25 to 30 feet in length of the small intestine. And it has a few different parts to it. So, right around in here is where the small intestine would feed into the large intestine, the cecum. This would be the ileocecal valve, would be the valve that allows stuff to move from the ileum part of the small intestine into the cecum part of the large intestine. And then from there, peristalsis moves the materials up the ascending colon, so that's over on your right side of your body, and then across the transverse colon, and then down the descending colon, and then into your sigmoid colon, into your rectum, and then out through your anus. And so, seeing kind of an overview of the whole digestive system, we have the mouth and salivary glands, and then the esophagus that takes food down to the stomach, then the stomach that passes food along into the small intestine, that big jumble in there. In the small intestine, it is fed with enzymes from the liver and gallbladder and pancreas. And so then, as the food moves through the 25 to 30 feet of your small intestine, that's where most of the digestion and absorption takes place. Ideally, all of, or at least most of the nutrients in what you ate have been absorbed. By the time it gets into your large intestine, the cecum, the ascending, transverse, and descending colons, and then get stored in the rectum. As the rectum expands, it triggers you to get rid of what you've eaten. And yep, that's the digestive system in a nutshell. And then a little bit about foods that we eat. So, water, along with oxygen, is the most important. Those make up the most important molecules for human survival. We can live without food for like 5 or more weeks, but we can only go without water for a few days. So, water is a vital part of what we eat and drink. And then carbohydrates, they're the most economical energy source. In other words, they're the easiest for our body to break down to get the energy that we need, and some of it gets broken down in the mouth. That would be the starches. But then most of it gets broken down in the small intestine. It reaches our bloodstream quickly. So, in other words, from the time you eat to the time your blood sugar level increases, it's a fairly short duration when you eat carbohydrates. And then if you get too much carbohydrate, then some of the excess can get stored in our liver for future use. But then if you're even getting more than that, that's where your body starts to store excess in the form of body fat. And then fats, when we eat them, they get digested in our small intestine. They peak levels of in your bloodstream of about 2 to 4 hours after you eat. So it's a lot harder for our body. Our body has to do a lot more work to break them down. And fats are used to do things like form cell membranes, to form the protective membranes around some of our nerve cells, and to build different hormones for our body. And then proteins. That digestion begins in your stomach. And if you don't eat enough protein, your body might digest some of your skeletal muscle to get the amino acids that you need. Then, if you eat too much, your liver might break the excess down and turn them into carbohydrates so then your body can break down those carbohydrates to get energy. And I have dietary guidelines here because there's so many different types of like diets and recommended nutrition and stuff, and seems to be changing on a regular basis. Even like the federal government's like food pyramid kind of thing, they realize, oh, that was a little too simple and a little skewed, and it kind of depends a lot on like your body and your age and how much physical activity you get. And what a lot of it just comes down to is eat in moderation, don't eat too much, and eat a decent balance of food groups. Most of the time, carbohydrates should be the biggest category, so like grains and stuff. And the next after that would be stuff like fruits and vegetables and meat. And then the smallest category would be like fats. And yeah, so eat in moderation, eat a good balance, and then more often than not, eat healthier whole stuff and not a bunch of processed stuff and a bunch of junk. And if you're doing that, you're probably getting just a great, perfectly fine diet to be healthy. All right. And then finally, I ran across this little picture that gives some kind of a representation of the digestive system. So yeah, like the teeth that is starting to break the stuff into smaller chunks, and then the tongue that is kind of like being a plunger to move it down, and you have the esophagus here that has a valve that decides that controls letting stuff from the esophagus into the stomach. Then the stomach is adding acid into the mix, and then it's pouring it here into the small intestine where the liver, the pancreas, and the gallbladder are adding substances so that as it moves through, it can get digested better. And then you have the colon that is acting as like the final control. Oh, the colon, did I mention reabsorbing water? If not, I should have. That's one of the main functions of the colon is of the of the large intestine is absorbing water from the chyme so that you don't have to drink as much water in order to stay hydrated, so that what leaves your body is relatively dry, so that we're not just wasting a bunch of the water that we drink by eliminating it. And then, yeah, so the colon acting as kind of like the judge for when to flush stuff down the toilet. But there's one key aspect of digestion that is not really being represented here. And I'll give you a second to think like what is missing for the big picture of what it's showing is happening. And if you realized absorption isn't being represented, there's no body here that is being represented as absorbing the nutrients, then give yourself a pat on the back. Okay, we have one more video question. It's number two. Video question number two. What cleaning substance often contains some of the same enzymes as your digestive system? What cleaning substance often contains some of the same enzymes as your digestive system? And the answer is laundry detergents. Laundry detergents. Because laundry detergents cleaning clothes, right, in the washing machine, and what's oftentimes on clothes, but different types of substances like proteins and carbohydrates, maybe from foods. And so it makes sense that some of the same substances that break down, that digest foods in our body, would be helpful enzymes for breaking down some of the particles and substances that can end up getting on clothes. So there you go. That's our little overview of the respiratory and digestive systems. And I'll see you next time.